This practice is going to be very helpful because we're going to be using what we just learned in molarity and also using the rice box. So we have to first write an equation. So you have a sample of 70.5 milligrams of potassium phosphate. So potassium is K. Do you know the charge for potassium? You're correct. It's +1. Phosphate, what is it? It's PO4 minus 3. So you're going to need 3 of these and just 1 of those. So potassium phosphate is K3PO4. Okay, so now it's added to silver nitrate. Let's go ahead and write silver nitrate. So silver, the charge for silver is Ag +1. Nitrate is NO3 minus 1. So silver nitrate is AgNO3, just 1 of each. So you're mixing together K3PO4 plus AgNO3. Okay, so to write the balanced equation, I'm going to write the charges in again, just to remind myself what the charge is. K is a +1. Again, although there are 3 of them, the charge of each one is +1. Phosphate is -3. Silver is +1. Nitrate is -1. When I'm doing a double replacement reaction, the positive ion to the negative, each one is +1, -1, so I will just need 1 K and 1 nitrate, potassium nitrate, plus silver and phosphate. I will need how many silvers? That's right, 3, and then PO4. That's because PO4 has a -3 charge, silver's +1, so I'll need 3 of silvers to make it neutral. Then I'm going to erase the charges, just so then they're out of the way. Okay, the next thing you're going to do is balance the equation. So 3 potassiums, 1 potassium, put a 3 right there. 3 silvers here and 1 here, so put a 3 there. So now I have 3 nitrates, and 1 phosphate. So it's 1, 3, 3, 1. Then write the givens underneath. You have 70.5 milligrams of potassium phosphate. So write 70.5 milligrams of this. Milligrams. 15 mils of silver nitrate. So 15.0 milliliters of 0.050, this right here. Molarity means moles for every 1 liter. Okay? Resulting in the formation of precipitate. So, which of these do you think is the precipitate? Potassium nitrate is aqueous because when asked about the nitrates, the answer is always clear. The each and all are soluble. It's all we want to hear. So the solid would have to be this. So the question here is, this is the precipitate, right? It says write the molecular equation for the reaction, which you did right here. This is the balanced molecular equation. What is the limiting reactant? Now, notice that I have 2 reactants here, okay? I can get the moles of this, and I can also get the moles of this. When you have 2 moles of the 2 reactants, you have to know which one you're going to run out of. So you have to put it into a rice box. They want to know the theoretical yield. When they ask that, they're really asking how many grams are you going to theoretically get or yield, okay, of the precipitate. So this is the precipitate, silver phosphate. That's what they're asking for. So to do that, we're going to change this to moles, then change this to moles and put it into a rice box. So let's try that. Okay, so we have 70, just do this. Go ahead and pause the video and try it yourself. Okay, 70.5 milligrams, K3PO4. 1,000 milligrams is 1 gram. K3PO4, the molar mass is 212.3 grams is 1 mole of K3PO4. So the mole is, for my rice box, for K3PO4 would be 3.32 E-4. Okay. Then I'm going to get the moles of silver nitrate. If you don't mind, I'm going to write it over here because I don't have room. So 15.0 milliliters. 1,000 milliliters is 1 liter. 1 liter is 0.050 moles of AgNO3 equals 7.5 E negative 4 moles of AgNO3. I'm going to write underneath here, 7.5 E negative 4. Okay, so this is this, and this is this, in moles. All right, in the beginning I have 0 of this, of these two products. I'm going to use X here because there's a 1 there, minus 3X here. I'm going to make plus 3X here, and plus 1X there. Okay, so in the end, I have to solve for X. So one of these will be 0. Okay, so what if X is equal to 3.32 E negative 4? Then this will be 0, and this would be a negative number. Therefore, that is not X. So I'm going to go ahead and erase that. Okay. So now, what if this were 0? Then X would be equal to, okay, this formula right here. Let me just erase this. It would be 7.5. Okay, I'm going to write this, okay? 7.5 E negative 4 minus 3X, so this now, is equal to 0. Now I'm going to solve for X. X is equal to 2.5 E negative 4. Okay, so if that's X, then this would be 3.32 E negative 4 minus 2.5 E negative 4 would be 0.82 E negative 4. Okay, so then this would be, I don't really care about this one. They want to know this one. So 0 plus 2.5 E negative 4 is 2.5 E negative 4. Again, if you start with moles, you're going to end up with moles. These are all moles. Okay, so the question is for letter B, which is the limiting reactant, is the one that you run out of. Therefore, it's AgNO3. So the answer for B is AgNO3 is the limiting reactant. For letter C, it's asking for the theoretical yield in grams. Just change this number in grams. 2.5 E negative 4 moles of Ag3PO4. 1 mole of Ag3PO4 is 418.7 grams. The answer is 0.10 grams of Ag3PO4. Okay, so this problem made you write the equation first. This is a double replacement reaction, getting a precipitate. You had to figure out which one is the precipitate here, silver phosphate, of course. You had to change the givens to moles because you have 2 moles right here. You can do a limiting reactant problem. You change them to moles and then do the minus x minus 3x plus 3x and x, getting the answers. You found what x is, okay, and which made this 0. That means you have nothing left over, so AgNO3 is the limiting reactant. And you were also able to calculate the amount of solid precipitate. This is a very good problem.